Hello! In this DDS tutorial, I will show you and explain one nice function. We call this function frequency family searching. You can see the standard vibration spectrum on the screen now. It contains a lot of peaks. It is not too clear what does each peak represent. Some peaks could be from the motor speed and its harmonics. Some peaks could be from a gearbox, fan vanes, and other sources. The decoding of the spectrum should be simple and quick, and the frequency family searching fulfills this requirement. Let's have a look at it. You can see the decoded spectrum now. It's the outcome of the frequency family searching function. You can see the labels with source descriptions, harmonics, sidebands, everything you need to see. But this process is not just one-click process how I presented it now. It needs some preparation. I will explain and show that to you. This is a demo example of a machine which contains the motor, gearbox and fan. We can see the motor speed, gear ratio, gear mesh frequency, fan speed, and the number of fan vanes. We can enter all this known information to the DDS tree. The motor speed is 3000 RPM. I will enter it to the motor properties in DDS. I have created the structure of demo machine. The motor is here. The gearbox is here. This is the fan with measurement point, and this is spectrum data cell. Now I right-click on the motor item and select Properties. I select the Speed tab. Now I enter the 3000 RPM as the default speed. The gear ratio is 0.35 and gear mesh frequency is 13 times the speed. I select the gearbox. I open the gearbox properties and the Speed tab. The default speed contains the information that the speed 3000 RPM is inherited from the motor. Now I enter the gear ratio 0.35. Now I select the Labels tab. I select the Gear Labels group. I press Add and enter GMF as the name of the label. Now I enter the 13 and then I select multiplying by the speed item. In this column you can select multiplication by speed or hertz, RPM, CPS, CPM, but we need multiplied by speed. Now we will enter the properties of the fan. The fan contains 19 vanes. I select the fan item and open the properties. Now you can see that the speed is 1050 RPM, which is inherited from the gearbox. I select the Labels tab. I select the Vanes Labels group. I press Add and I enter name of the new label vanes. Now I enter the value 19. Then I select the multiplying by the speed item and confirm by OK. I select the spectrum data cell now. I right-click on the graph and select Families item. All known peaks in spectrum are decoded now. The list of families is below the graph. You can see 4 families. The frequency displayed in second column here is the carrier frequency of family. The RMS value is the sum of the carrier RMS and all modulation RMS. What are the modulations? Harmonics and sidebands are the modulations. The RMS percentage value is the proportion of the family RMS to total spectrum RMS. You can see that the sum is not equal 100%. It is correct because many peaks are contained in more than one family. You can select each family in the list. Here is the motor speed family. You can see the carrier frequency and harmonics. Here is the gearbox family with carrier and harmonics. GMF family, carrier frequency and sidebands in this case. And the vanes family with carrier frequency and third and fourth harmonics. The second harmonic is probably here and it is not labeled because it's too low. Maybe I should explain in more details how the peak is found. Actually, the peak is 5 spectrum lines, where the highest one is in the middle and the sideband lines decrease. We define also the noise threshold. The peak exists only when it is higher than this threshold value. Usually, this limit is equal 1% of total RMS of spectrum. You can see only the first half of family function now. The frequencies defined in properties are displayed only. I can hide each of them by the checkbox in the beginning of line, here. The gearbox speed family is on and off. Now I hide the motor speed off and on. I can do it at once by pressing Hide All button. It is here on the right side. Hide All. We can see the hidden lines as light gray lines. What remains in the graph? We can see lines which need to be decoded. This line, this line, this line. And also small lines which are lower than the noise threshold. I can see the threshold limit, which is 0.1 mm per second. Now I press the Find button here. The new label HARM1 appeared. The new family is found. The new family HARM1 was added to the list. The carrier is 522 Hz and it contains 2 harmonics, the second and the third. Now I should speculate about the source. Now I can ask why the families function is so useful. And yes, it is of course, because it can describe all known sources in the machine. Then I can hide them to look at the residual spectrum. The lines with known source do not obstruct my view. If I hide all known families now, then only peaks under threshold remain in spectrum. It means the complete spectrum interpretation was done. Thank you for watching this tutorial.